Welcome. This is an intro to integration. It's Calc 2 at my home institution. So hopefully you've had, if you're watching this video, you've gotten a taste of some basic integration. And so this video is meant to be a very, very, very quick review of some fundamental integrals. And by saying fundamental, these are ones that you should just know off the top of your head. Many of the integration methods that you're going to be learning, the goal essentially is to apply those methods in order to somehow convert the integral into one of these fundamental ones whose answer you will eventually just know. So let me go through many, maybe even most of them. And so the first case is the integral of a constant. And so here it's the integral of a dx, where a is a constant. And this is ax plus c. The polynomial. You can have a polynomial integral of x to the n power, where n is not -1. And this is the integration power rule, which is x to the n plus 1 power divided by n plus 1. So add 1 to the power and divide by that new power, plus some constant c. Exponential is another fundamental one. So the integral of an e to the x dx happens to be the same, e to the x plus some constant c. And then you start getting into some more obscure ones, such as these power functions, the integral of a to the x dx, where a is some constant. And this is a to the x power over the natural log of a plus some constant c. And there are some restrictions here. A cannot be 1. And it has to be positive because of the natural log function. And then you have the integral of x to the -1 dx. So this is when n is -1. In the top right for polynomial, n could not be that, but now it is. This is the same as the integral of 1 over x dx. And this is the natural log of the absolute value of x plus c. So this comprises most of the fundamental integrals. The next batch correspond to trig functions. And again, these are ones that will be advantageous if you just come to know them off the top of your head. So first one, let's do the integral of sine of x dx. And this is going to be negative cosine of x plus c. Then you also need to know the integral of cosine of x. And this is sine of x plus c. Integral of secant of x is the natural log of the absolute value of secant x plus tan x. Again, plus the constant c. And we also want the integral of secant x tan x. And this is going to be secant x plus c. It's useful to know the integral of secant squared. And so like with the previous ones, if you haven't been going through this in your mind, think about what function has the derivative of secant squared, and you think of tangent. And then there's a bunch more, so let me progress through them. We also want the integral of tangent of x dx. This is the negative natural log of cosine of x plus c. You can pull that negative sign into the natural log and write this as the natural log of secant. Both work. We also want the integral of cosecant cotangent. This is going to be negative cosecant of x plus c. Let's also get the integral of cosecant squared. This is going to be negative cotangent. The integral of cotangent is going to be the natural log of sine and we didn't do the integral of cosecant. Here we have negative the natural log of cosecant plus cotangent plus c. Let's see if we missed anything. We've got sine, cosine, tangent, cosecant, secant, and cotangent. We have secant squared and cosecant squared. We've got secant tangent and cosecant cotangent. So that looks like we have all, and then there are some that are getting trig functions in reverse. So what I mean by that is the integral of 1 over 1 plus x squared. And this is arctan. And this one isn't as critical to have memorized at this point. You're going to get to a method in probably Calc 2 where you are going to learn how to actually solve this and other ones like it. But that's how you'd be able to prove or rederive that arctan is the integral or the answer of this integral. So again, this is a list, a fairly comprehensive list of all of the fundamental functions whose integrals it would be advantageous to just know off the top of your head.